So, good morning everybody. Welcome to our session about SUSE architectures for SAP high availability. So we are going through some setups, how to make SAP applications or workloads high available. My name is Fabian Herschel, working directly for SUSE in the SAP headquarters in the SAP Linux lab, and I am responsible for HA solutions around SAP. And as we are HA experts, we have not only one presenter, but two of them, so we can take over if one is failing. So going to you, Bernd.
Okay, thank you, Fabian. My name is Bernd Schubert. I'm working also in the SAP Linux lab in Germany, together with Fabian on all our HA solution that we have. I joined the Linux lab team 1.5 years before, and yeah. The most of what we are doing is around SAP HANA, NetWeaver, and S4 HANA. Yeah, and this is what we would like to present today.
Exactly, and today our rail map through this session will be to have an overview about HA and in front about /4SAP and our cooperation with SAP. Getting an overview about our solutions, then a bit more deep dive into one solutions about getting SAP NetWeaver and S4HANA applications high available for ENSA 1 and ENSA 2. We will explain what that is and what the difference is. And then going also to some things about the cluster connector, what is it, how it has been used, and then we have some up to three, depending a bit how many time we have at the end of a session, video-based demonstrations where you can see our cluster working together with an SAP workload.
Okay, our relationship between SAP and SUSE is very strong and goes back to over 18 years. SAP trusts SUSE since this long time and built their own infrastructure based on SUSE products. So the SAP Cloud Platform is based on SUSE Linux Enterprise Storage and OpenStack Cloud. That's one example for this trust that SAP has on SUSE. SAP HANA, the first certified SAP HANA instance was running on SUSE. This is the first operating system for SAP HANA was SUSE. Yeah, we have a joint testing and development in SAP Linux lab. That means each product which is coming up from us and from SAP is tested by both sides together to make to be sure that the systems are working on the new products and new operating systems. As you can see, mostly a lot of HANA systems running on SUSE, 90%. 100% of the SAP Business One appliances on HANA running on SUSE only. Therefore, we have built a special image to make the deployment of this system reliable, quite easy and straightforward for the partners and customers. Yeah, and with /15 we have implemented some new features. We will have a session for /15, especially here on the SUSECON. Major features or newer features are the performance and configuration on tuning. So that means we have subtune and subconf improved for SAP workloads. We have the driver support for the Intel Optane DC, the persistence memory things, and yeah, we have updated and improved the SAP HANA resource agent. So for SUSE Linux Enterprise Server for sub applications 15, we still have new innovations which will help you to run your SAP workloads much more reliable and yeah. Okay. As you can see, we are able to assist or support multiple environments. So you can install SUSE Linux Enterprise Server and your SAP workloads on on-premise it doesn't matter if it's virtualized or bare metal. We support different architectures. So you have, as you can see, we have the X architectures, system set and power. We also have images available for the public cloud, so you can also run your SAP workloads in the public cloud. All of them we are supporting this. So there are instances available which are customized by our public cloud team, and they provide together with the partners AWS, Azure, Alibaba, and Google to make this instance available for you to use them. If you would like to have more influence on such a cloud infrastructure, you can have a private cloud, and for that we have also products as also SAP uses the OpenStack Cloud and SUSE Linux Enterprise Storage, and then you are responsible for all the content, and you are able to build your own images and customize the images as much as possible to your needs to run your workloads. Okay, next one. Okay, for more or less for each SAP product which is available, we have an answer. So especially, as you can see, for SAP NetWeaver and SAP HANA and S/4HANA, we have the SUSE Linux Enterprise Server for SAP application and the high availability extension. Together with that, you are able to run this kind of SAP products as much as possible reliable. For the SAP Data Hub, the answer from us is the SUSE Container as a Service platform called CASP. And for on SAP Cloud Platform is based on SUSE OpenStack Cloud and SUSE Enterprise Storage. And it doesn't matter where you would like to run this, you can run this on-premise or in the cloud. So all these products are possible to run in both worlds, in the old on-premise, and the new one in the cloud infrastructures. Okay. Next one. Now we we make a deep dive in the high availability functions, and for that reason I would like to explain you the redundancy mechanism which are available and which we are using and which we have to take care for. The first one, it should be a green signal, a traffic light, and as you can see, it's an LED-based traffic light. We call this internal redundancy. Why? As you can see, there are a lot of diodes, and if some of them are failing, you can still recognize it's a green light, and it doesn't matter if one of them or two of them are not working. So this is called, or we call this internal redundancy. That means if one or two services are not available, the whole function of the traffic light is still possible, or still you still see it's green. Okay, on the right side, external takeover. This is a different mechanism. We try to figure out the example from the real life to explain it a little bit. There should be a soccer field. And the team, one of the team member was hurted, and you have the trainer outside of the field and the standby player, and the trainer has to monitor every time his team when it's playing. And if something happened with one of them, he has to take care and make a decision if he can continue or he have to replace. So in case he have to replace, the decision maker, the trainer in that case, replace the player, and then the game can continue. And this is what we are calling external takeover. So you have a mechanism who monitors a system and take care for the system can continue. And a mixture of both. A good example, the hybrid redundancy scenario is the SAP HANA scale out. In the SAP HANA scale out, you have the functionality for auto host failover. So you have a standby node internal of the database. And so HANA himself is able to make a self-healing mechanism. So if one service or one server is failing, HANA himself is still operating because he can move the data, the resources from a fail node to a secondary node. And if you have a system application, so you have two HANA scale-out systems, and something happened with a whole site, you need an external monitor service to take over your database from one side to the other side. And then we have this situation mixed together with the internal redundancy, and then we are talking about a hybrid, high availability scenario.
Yeah, and with that we are going to the first example of such a setup or such an architecture for an SAP workload. You all know the SAP HANA database, and it could be configured to be in system replication. However, if I have it in system replication, I need someone to take care about if one instance is going down and to switch over to the secondary side. And even more important, to monitor continuously or regularly, is the secondary still in sync with the primary, or is there any gap in the data being transferred between the primary and the secondary? In our cluster, we have implemented that with a master-slave or multi-state resource. You see that the primary side is the dark green is promoted, and this is the status that the SAP HANA is running as a primary, so as the system replication source. The light green, HANA is running as a multi-state slave or demoted status, and this is how you can find it in our cluster. So the resource agent to do that is named SAP HANA, so it is really doing changes like starting, stopping, doing a takeover with the HANA. And we have a second resource agent, it is called SAP HANA topology, and this is just viewing about is there a HANA on this machine, is it configured as in system replication, and so on. And here beyond our cluster you can see the system replication by SAP in the blue and orange things. So the databases are writing to the memory, of course, if something is coming into, they are writing on disks to make it permanent. And the primary is then sending to the secondary deltas or log shipping. You can define that in your setup to get your HANA system replication set up. Coming from this simple things, which is the performance optimized scenario where you have the fastest takeover to the secondary side because most of the things is already loaded to memory. You can also decide to go on the upper right side with the cost optimized scenario. So you have a second SAP HANA database been running on the secondary side. If you decide to do it in a way that you want to say, okay, I don't want just a cost-intensive server being on the secondary side, just waiting for a takeover. Yeah, so it's depending a bit on your expectations, how fast should be the takeover in your cluster, and what are you willing to pay for. You can also have chain or multi-target situation where we in the cluster only are viewing on the first system replication for first. So in the chain it could be that you see that by this dotted line it could be another maybe very remote data center. Then you have high latencies, typically not fitting a cluster which has fast decisions. So normally only the first two of those nodes are under cluster control, but we will see on the rail map for our future things we are thinking about that maybe in the future we'll also remove such limitations. Then last not least, the scale-out thing Bernd has already told about. You have just a multi-box HANA syncing with a multi-box HANA, so it gets much more complex because you have already an SAP cluster running on the left side, you have an SAP cluster running on the right side, and our cluster must monitor both of them, so I call them swarms. So like an application swarm working together, and if this swarm says we are failing, then our cluster is doing the takeover. So far with SAP HANA system replication. And now we come to a thing about a complete SAP system like NetWeaver or Business Suite or S/4HANA application server platform. So where do we need the cluster here? We have inside the complete thing of SAP already maybe the databases being high available. We have learned that we can have it as SAP HANA system replication. We can already enroll it onto nodes. You can also have the, SAP web server availability, because you just install more than once. And since I don't know exactly which subkernel versions, each application server could take over the roles of others. So each could run the booking to the database, each could run the badges, and so on. So we do not have this special rule of the primary application server anymore. It's still named that way, but you have something like an inside HA here. If you are using logon groups, then you can directly say your client just log into this logon group, and the message server will then redirect to one of the available application servers. So this is also already high available from an SAP point of view. But there's one single point of failure, and this is inside of the ASCS or SES if you have a Java workload. You have an enqueue server inside this central services instance which is processing the SAP logs. SAP logs are not directly database logs. They are more complex. They could be on a logical object inside of the SAP application. So this is a very, very important thing. If the enqueue server would die and would lose its logs, all sessions on all application servers would be closed, and all clients would need to log in again. And you maybe have also some rollback of SAP transactions because they are not fulfilled completely. And so this is really a very important thing. And so we added this to the cluster. So we say the mandatory cluster setup is really to look on the ASCS ERS pair and to make sure that you do not lose your logs whenever the ASCS is dying, or process is dying, or the machine is dying. Optional clusters we have already talked about could be to put the application servers itself in a cluster. So the cluster is something like a provisioner for the application servers, but you can do that also by starting them on demand. And the database could also be solved. It could be either Oracle RAC for NetWeaver, or it could be SAP HANA system replication for NetWeaver and S/4HANA. So we are quite safe on this side. So then SAP had the situation that in the past, they already for years they had the enqueue replication servers, and sometimes customers were a bit claiming about it's too complicated to set it up, and we will see how now SAP has updated their ASCS ERS enqueue mechanism, and what are then consequences for our cluster. So here on the left side you see the not old but the current thing, the ENSA one. It's the enqueue server standalone architecture in the first version. And whenever the ASCS here would fail, the ASCS must exactly start on the server where the ERS server was running before. Why? It is because the sync mechanism was done by shared memory. And if the ASCS would find an empty shared memory, it would just think, okay, we are starting from plain, I delete all logs, and so you would have still a loss of all logs of your system. So the cluster must have a very straight thing that it always moves the ASCS to the ERS side. And then, the customers sometimes complained about that because this also reduced the clusters to 2-node clusters only, because there was no value add for having more cluster nodes if you only have one target node to go to. And you see in the last step for the normal production, then you have an exchanged role of a cluster node. So the ERS will be again by our cluster being spawned up to the first node. So you have a spawned up system replication between 2 nodes. So if now the second node would be failing, you have the log safe on node 1. So because of these limitations, together with SAP, we have thought about how could we solve that, and the SAP kernel developers brought up the ENSA 2 architecture. The ENSA 2 architecture could now also sync from the ERS side to the ASCS side via network. And this now has some consequences on our cluster, because now first it does not need anymore to move the ASCS to the ERS side, so we could have also multiple node clusters for multiple systems and so on. And we can continuously have a spawned up situation where always the ASCS and ERS are running on different nodes. The only thing the cluster should not do right now in a multiple node clusters is to move the ASCS exactly to the node where the ERS is running. So if you have a 3-node cluster, the ERS must be moved, for example, from node 1 to node 3. We will see that also later in a video. For our cluster, I do not. I need a bit to speed up if I look on the timeline. We have the same resources for both concepts. It's really a very simple concept to set our cluster up. It's only that you cover the IP address, which is the access point for the clients. You have a file system which is needed to have the work directories and so on. And you have, of course, the SAP instances for the ERS, ASCS and the ERS. So while formally with ENSA 1, the cluster must guarantee, and this looks maybe a bit strange, that it restarts the ASCS on the same node only for admin things. So if the admin stops the ASCS, starts it again, it comes up on the same system, and you would say, now my logs are gone. And yes, this is the badness of this concept, but SAP has some situations they need to trust in an update process that the ASCS is not being moved by the cluster and comes up on the same node. And SAP, of course, has for this administration procedures safetiness for the logs. So no logs would be lost if you directly follow the SAP recommendations. Whenever an error occurs, of course, ASCS must move to the ERS. We have already learned that. So a cluster rule in the past in our NetWeaver-based setup guides would be move over to ERS. And then, of course, we say the ERS must be moved after the node is coming up again. So you have again spawned up system replication between those two. ENSA 2 now is that you have the possibility to restart either on administration or on error, because if this node is still available, the cluster first tries to start up the ASCS. It's the fastest solution not to move, and only if this fails, the second escalation step would be to move over to a different node. So, and with that, I come to our SUSE cluster connector.
Okay, yes. Why we have this and why we need this. Please think about you have an HA-controlled SAP instance, ARS, ESS, or HANA system application, and your SAP administrator will do some maintenance on the SAP environment. He stops the system, and what will the cluster do? He will interact with this behavior because he's thinking something went wrong, and he will start up the system again. And if the SAP administrator is doing some maintenance tasks during this procedure, that could end up in a very dangerous situation. And for that reason, we have built, or we have developed a tool which is called SAP Cluster Connector, which interacts between the operating system and the SAP system. And this gives us the possibility to set up states in the cluster if a command is triggered by a SAP administrator over the management console or over CLI, and set up a mark in the cluster configuration. Okay, this behavior was expected. This SAP system was going down, and the other way around. If you do it with cluster commands, everything is fine because the cluster will recognize this was an expected behavior. Okay. This integration is certified since NetWeaver 730.
30, then also 740 and now.
And with the new version, this SAP Cluster Connector 3, we have improved this interaction between the SAP commands and the cluster commands and the operating system. So we see here there are SAP instance resource agent versions. So you can see from the SAP point of view with SAP tools the integration into the cluster, or the cluster integration from the SAP point of view. And also you have the possibilities to trigger failovers with SAP commands inside of the cluster. And the next one, we will also see the integration from the operating system. This is a hawk picture, the management console for the cluster, which is provided or which is installed with the pacemaker tools, pacemaker himself. You see an overview of all the SAP instances, and you can also interact with the SAP system with cluster tools. And this integration is certified last time this year in January. With the S4HANA
upper platform 1809, so it was the first certification of an HCL vendor with the new ENSA 2, so we are on the pool position right now.
Okay. Next one. Okay. This should show, this is an overview that all the things what we are doing for SAP HANA on the left side, all the things are documented and available as a best practice on our documentation page. We also have the NetWeaver and S4HANA integration with the SAP SUSE Cluster Connector. All the things are documented and certified by us in the SAP Linux Lab. And working closely together with our partners, cloud providers and other hardware partners, they can use them and they can build their own solution for their own infrastructure. And most of these documentations are co-branded, so they have the documentation available on their website and also on the SUSE Best Practice website.
So this I would say it's also our kind of openness, so this documentation really available for you. And so what we did in the past, Bernd already said it, we have worked together with a lot of public cloud providers, with AWS. It was the first engagement, but we have also worked together with Alibaba, with Azure to get them working in the cluster. Google started by themselves and surprised us with a running solution. And so nearly all big parties here have it already running. Also IBM Cloud has it running, and I don't remember if there's some more, but the documentation we have focused a bit with which company we have a documentation on public web pages available for you.
As the documentations are public available, they can adapt the solutions that we have to their infrastructure quite easy.
Exactly. So our not road but rail map in the future, what we are thinking about, so it's not really an order what we want to do, but it's that we think about to do something about diskless fencing. If you know pacemaker a bit more in detail, you know maybe about the fencing mechanisms, but it's not good to have a shared disk in cloud environments. So we are exploring the diskless fencing, which is available right now. But we need to test it with the SAP workloads. It's not only enough that it is available from the community, it must be tested against SAP. Yeah, does it really fit? Then a silent takeover, it's an SAP technique that a client gets over, can go to the takeover node and gets its session being recovered. So for read sessions, it just can continue. Already the internal session pointers are available on the secondary side. We are going for Azure for HA of scale out and dynamic tiering, or the technically follower we are looking on. So we are moving from dynamic tiering to the successor technology. Star topology is the multi-target thing. So we are looking on what is happening if we have a primary which has two secondaries, and how maybe could we in the future also do that in the cluster, or at least if we focus on one system replication, is there anything we need to encounter or to change in our code for that? So now today with closed gates, because it will be shown in the session of Bernd this afternoon.
Yeah. I know the motto is to be open, and this is closed. Yeah, we will announce a new product which is available as best practice in cooperation with one of our partners this afternoon. And yeah, on Thursday we will have the gate open for this.
So if you on Thursday we have the second time this tech talk. So with that we come to our demo time. So we are now try to switch over correctly to our videos, and we will comment them live. So it's not a video just running with a video tone, so not to bother you. And I hope that the videos will work right now. Fine. So for first we will have a look on the SAP cluster integration. So what is the SAP SAP SUSE cluster connector really doing? And we see we have a multiple node clusters here on the terminal side. You see that in this case it's a 4-node cluster. We have a resource group for the ARCS thing running on Beluga 21, and the resource group running on 23 for the ERS side. So this is what you expect from Pacemaker. It's basics. But what is now new with the cluster connector? So we are looking on the second side onto the SAP point of view. And if the admin would move to the management console, now we see the SAP point of view. We see the database, HANA being installed with a different system ID, and we see the EN2 system, which is our S4HANA business suite upper platform 1809. And it consists out of 2 dialogues instances we have already discussed with HA, an ASCS and an ERS instance. So how now to see about the integration of a cluster, so getting information of a HA integration inside of a SAP management console. You click on the system level and you get a new tab named High Availability Configuration. And if you open this tab, open the pull down, you get a list of tests being running on the entire system inside the cluster and also on the other nodes of the SAP system. And you can see here that the SAP itself is running tests, and also we have integrated some. So one of the typical tests SAP is doing is, are there at least 2 ABAP instances implemented, because you want to have this SAP HA capability of your system using lock-on groups and so on. And this is being shown. This is not what the cluster connector is doing, but this is the SAP side of this integration. And now we are showing in this case at the end of the list, there is one test which is running by our SAP SUSE cluster connector. So we are checking right now if you have at least a successful, at least a minimum version of a SAP HANA instances resource agent installed, so it fits to your installation. So whenever we from SUSE would add additional tests here, they will come directly to the SAP Management Console. If you go now to the ASCS instance, you get also an age availability information pull down. And if we open that, we can see the HA is active, we can see the product version, and we can see even the cluster interface version. Due to SAP restrictions in the how to name it during the certifications, the string is exactly the same. We just added one information here that you get the package version of a SAP SUSE cluster connector being used. You can see the active node, which is Valuga 21. And if you remember the demo before, yes, Valuga 21 is correctly detected. So you can see inside the SAP Management Console what the pacemaker is doing, or where the pacemaker is running this instance. And this is new. In the past, we had the problem that if SAP and the OS department are not connected directly or are not working together, they are lost in getting the information. What is the pacemaker doing? What is the SAP doing? And now you can directly see that. You can even see the other cluster nodes being available for takeover of this instance. So Valuga 23 is the first one because it's the active. It's the thing running this workload. And you can see all other nodes are potential takeover nodes. So with that, we already have explored about that we can really see in an SAP tool. It can be run by command line. It could be done in the Microsoft Management Console if you have integrated the SAP part, how to do it. Now we are doing a start and a stop of SAP instances. In the past, this was really pain in the hands if you do that, but now it is really that the cluster is working integrated. So you have here, I call it synthetic logs. So we have just created some logs in the ASCS because we do not want to click too much in the SAP system. We just said, please command fill some logs into the ASCS. We have a script to recall them, just to retrieve, are they still available? And now we can see, okay, the ASCS has those logs being stored, they are safe, but now we are doing some things in the past, they were really ugly. So we go to the Management Console, we need to select first on the tree the ASCS, so that the context menu is really matching this one, and we are stopping the instance from the SAP tool. We're doing it by the hard shutdown because soft shutdowns does not work together because the substart framework is not able to tell the cluster about the soft shutdown. So always take please Swiss stop. You see that the rule in the cluster is now set to stopped. And in the Management Console, you see that the message server, enqueue server has no start time anymore, no elapsed time anymore. So they are just being stopped correctly. So both sides matching together. And this is also new. In the past, you can be completely disconnected. Starting the ASCS again is being shown in the cluster directly by the starting thing in the CRM on. And after the ASCS being started completely, we want to check how does it show up in the Management Console, and we have stopped and started the ASCS. Are our logs available or not? And we have answer 2, so the stop and start is allowed. So you see new elapsed time, new starting time. Yes, this is really a new instance. And new PIDs, so process IDs. So this is not a fake, it's really a new instance being started. And The active node is the same, so it was not been moved over. So this is what answer 2 should work like. And now we are going to the console again, checking if the logs are still available. And we are checking the timestamps. Yes, they are still available. So this is what was not able in the past by restarting the ASCS with answer 1. With answer 2, this is now possible. So, last not least, we are checking also about some details in the timestamps. You need to, if you find some differences in the milliseconds thing, it is because this, if you resync from the ERS to the ASCS, the timestamp is being taken from the ERS timestamp. So it's changed, but it's the same log. So it's only the last digits which are a bit different. And now we are doing something we also was not possible to do in the past. Could we even migrate an ASCS to another node just using SAP command? So first of all, we have a new command by SAP. So this is how this works. SAP codes some things, we are coding some things. And the command is, in this case, the subcontrol. We do it right now on the command line. We are providing the instance number, which is 00 in this case. The function is called HA_failover, and we don't give the cluster the hint where we want to fail over. We have a multiple cluster node, and we need to trust that the cluster does not take over to the node where the ERS is running, if ever possible, if there's another candidate. So the ERS node should be the last. So the cluster should work, evacuate 21, go to another node, but do not go to 23, because the ERS system was running there. You see that the instance has been stopped on Valuga 21, and it is moved to 22. So the cluster has detected the Valuga 24 is not the best candidate. It would be one of the candidates, but not the best. Sometimes you need to update the Java management console that it has the new status. So now the active node also in the console has been shown up as Valuga 22. And you see it as the first of the available nodes for the ASCS. So we did a bit cut the session because we did that already with the ERS, but this would be a bit too longish here right now. I don't want to bother you. And of course, we also check if the logs are still available. Yes, and also during this takeover, triggered by SAP needs, not by a failure of the ASCS, the logs are still available, correctly transferred to Valuga 22 by the network transfer of the logs. This is the new thing with answer 2. So the new thing with the new way how is SAP doing system replication, not system replication, log replication, anchor replication. So, and ERS is running on 23, so we really have organized from both views, from cluster view as well as from SAP view, that the cluster did the correct decision, and also both views are still matching. And we can even do it in the graphical console. You have seen that Valuga 21 is not showing up. It is because we have still an applying ban rule in the cluster. If we are moving here, we are banning this cluster for 5 minutes, and it's still available. So you see in the SAP management console, there is a ban rule for 21 because it's not listed as a possible takeover node. So even if we click in the graphical console, it's moved correctly. In this case, the graphical console has only the possibility to apply a specific node where you want to fail over. So this is why we have shown you this with the command line, where you leave out this hint, or you use the graphical tool and can even say, I want directly to move to 24. So, and the cluster did it. And last not least, we want to check if the logs are still available. And this is the case. And all of these tests must be done during such an SAP certification we have passed. And if you have this capabilities and this test passed, and also something Bernd is showing afterwards, hope we have time enough, then you get your SAP cluster integration and get SAP certified integration for S/4HANA. So this was the first video. I hope you, oops, now the video is not closing like it did before. Okay, I do it differently.
Alt-Tab. Alt-Tab.
Okay. No, it doesn't work. Okay. So this is also live. Let us close it that way. And now we are showing something. It's the rolling kernel switch.
Okay. So the integration, one of the proof points for the integration is the rolling kernel switch. Fabian, can we go shortly back?
Yeah.
So we are using the same infrastructure what we have shown as seen before, but in that case we have only 2-node cluster. At first we check the version, and the rolling kernel switch means an SAP administrator send only one command to the SAP system after his preparation, and then the system will do an update by himself. So it's an internal mechanism. What we have to prove that this mechanism is working with our cluster. So, and we do a rolling kernel switch from version 22 to 28. Okay, can we start?
I tried to start it again. Hopefully it works. Yeah.
Okay, so we have checked the version 22 in the SAP Management Console, and now the SAP administrator copied the binaries from the version 28 to a specific directory. Where the instance are looking on during the boot, and copy the binaries to the system, to the instance over to the local file system. So we also set some logs to prove that the mechanism is working also with connected clients and with running activities. Okay. The command to do the rolling kernel switch, it's quite simple. We're using subcontrol with the function update system, and that's all what the SAP administrator have to set up to update all these 4 instances with one command. So this is the overview. The rolling kernel. So he already triggered the command. And now we see, as first, the ERS is stopped, and during the start process, the new binaries will be copied over to the file system for the ERS, and yeah, we can verify that. Okay, we have a new elapsed time for 8 seconds, so the system was really rebooted, and yeah. It's the same host as before. So there was no move over. We don't see any error messages. Okay, ERS update is done. As next, the ACS is stopped. And during the start process, the new kernel information and new binaries will be copied to the ACS instance. And as you can see here in the cluster console, there's no error message or no message shown that something went wrong, because this situation was expected, because of the integration between the operating system and the SAP system. So we also see a new elapsed time for the ACS. And I guess we have to verify what happens. So now everything, the next updates are running outside of the cluster because only ACS and ERS are in the cluster integrated. Now we can check how far is my rolling kernel switch. And we have two possibilities for that. One of them is a subcontrol command, the get update system list. And now we see the ACS and ERS are still finished and the dialog instances are still queued or scheduled for the rolling kernel switch. The dialog instance 1 is already in the stop process, so we should see it here with a yellow mark. That's what Fabian also mentioned. Sometimes the Java management console is a little bit slow, so you have to do a refresh manually. And then we see, okay, now it's going yellow. And we verify the versions, and we see 28 for the ERS, 22 for the dialog instances, and 28 for the ACS.
So 2 of them are already updated.
Yeah, perfect. So we tried the scenario to do it much more realistic. During the certification, we do this during a high load phase. So the test routines from SAP triggers a lot of interactions with the SAP system. And this must be run and working very well. And we did this here only with the logs to verify. We put logs in the system, and later on we will verify if the logs are still there. And yeah, the dialog instance still is now starting. Okay, we see it's still the old
view.
Old view. So we have to update it again. Okay, now we see 2 of the processes are still have a new start time, and the other 2 missing. And if we check from the console, the update list, we'll see, okay, it's still in the starting mode. And we also see yellow, the same color as from the management console. So for the dialog instance 1, it took a little bit longer. The dialog instance 2 is much more faster. And if you have 10 of your application servers for connecting the clients, he will do the rolling kernel switch is running over the whole infrastructure, or over the whole SAP system. Okay, checking again from the management console, do a refresh. Okay, all 4 processes are running. And checking from the operating system, now the last dialog instance is in stopping mode. Okay, 3 of 4 are already updated. So dialog instance 2. There we can see now a function which is not possible in the cluster control environment. Okay, first version check. Dialog instance 2 have 22 and 28, 28, 28. Perfect. So for dialog instance 2, you will now see there is a soft shutdown, and this is not possible for instance which is running in a clustered environment. But soft shutdown in that case means all clients have the chance to finish their transactions before they cut it over after the
timeout.
A timeout, yeah. So the SAP system will wait for a timeout, and this timeout, for this timeout, the clients have the chance to finish their transactions. So did not lose your work. Okay, do a refresh. Okay, everything is stopped. Now we check from the operating system. Okay, it's still in starting mode, yellow.
Click.
And back to the management console. do a refresh. And we did not cut anything from there. It's really this fast. The whole procedure is now running in around about 9 minutes for these 4 instances. And the SAP administrator has nothing to do with the cluster himself. He only triggers the command, and the interaction from the SAP SUSE cluster connector and the SAP system do all the other things. That makes the life much more easier. Okay. Looking a little bit around to do some things. During the start process, the binaries are copied over, and now we can see Dialog Instance 2 still have, or now have the version 28 before the system is completely up and running. Yeah. Okay, now all processes are running. Checking again from the operating system, and the update list is empty. Why it's empty? All processes are done. So no update processes in the pending mode, and the whole SAP instance or SAP system has the new kernel. That was quite easy.
So with that, we are going back to the presentation because for the third demo, we are a bit running out of time, but you can come to our booth and then we could show it up at the showcase. It is only 5 minutes, but then we would be over, and I want to give you also some minutes for Q&A. So I'm just trying to jump back to the, jump back to the presentation.
Yes.
Worked. So first of all, that we do not forget that, please participate in the survey about this session and earn points by doing so. So you are getting points for each session you attend, you get points for such surveys and so on. Further information we have for you on our website is we both are writing blogs with thematics towards zero downtime. And you can just follow this link. You will get, you can write it down, you can photograph it, you get also the PDFs after the SUSECON. They will be available, at least it was always in the past. Also videos will be available if they are working. And so this is our tag where Bernd and I am publishing new things. We also try to get these videos you have seen that we will do audio added to the videos, and then are locating wherever in YouTube or wherever we find a good place for these videos, and then the blogs will point to that. So you'll find our new things always on SUSE blogs C tag towards zero downtime. Then we have best practices. Bernd has shown you these with wheel of /for/sub applications with all those contributions of our partners. These are available on SUSE best practices. And I don't want to bother you with the other links. You can just follow them. So with that, we open for Q&A. Are there questions around those solutions, or maybe if you have other questions, come to our booth or whatever.
So where is your booth?
Our booth is in the showcase, and there are 4 SUSE things closely together. And if you go to the SAP booth, we are directly in the neighborhood, so you can't miss it. It's nearly directly in the middle of the showcase.
And it's /for/sub application.
It's named /for/sub application. So because we are working for this, so just look for this string on the booth and you will find us.
The SAP SUSE cluster connector, I know it's available for SLES for SAP. Is it 15 or is it 12 or is it all supported?
I repeat this question. So the question was, is it only available for /15, because this was the certified one, the SAP SUSE cluster connector. also for /12. It is always for for sub applications, because this is our add-on in this product. It is also available for /12, but we decided, because it is a bit expensive to do such a certification, only to do it with a new product, but it's also possible to do it with /12. And we will publish in the future also a setup guide, which either says you can just do it also with /12, or documenting what is different.
And platform-based, we support the X as the Intel architecture and the Power LE. But for Power LE, we did not do the certification up to now. To certify a different architecture, we have to do a new certification. But this is not done up to now.
Yeah. But this does not mean SAP supports that. So there are two statements from SAP. You can run each SAP workload within a cluster if the HA vendor does support your setup. So if we say, go ahead, you can do it. The certification is only a plus. It's like a sign, oh, how closely is this HA vendor working together with SAP? It does not say anything about support yes or no. Yeah.
If the product is available, you can install it, then it will be maintained by us.
Yeah.
Or if it's certified by SAP too.
So with that, we hope you enjoyed our session, and thank you for your time.
Have a nice day.